Thank you, Waleed, for the introduction and for inviting us to participate in today's session. Excuse me, and thank you to all the attendees who are able to participate in this one. To give you a brief introduction, my name is Dave Tracey. I am the Director of Global Channel Sales for Lumin. You may have heard of us. If not, we are a Canadian firm with a number of international locations, but we have been involved in many different industries, primarily focused on innovative and rapid and practical microbial monitoring technologies. But with the advent of COVID-19, we've gotten involved in wastewater-based epidemiology. So it has become a major area of focus for us. And that's what I'm here to talk to you about today. Now, this slide is just an introduction to the concept, which most of you, if not all of you, have some familiarity. But the adoption of WBE has significantly expanded as a result of the pandemic. Prior to COVID-19, it may not have been something that most people, even in the industry, had much knowledge on, but as we grew to understand more and more about what the capabilities were of wastewater-based epidemiology, and we realized that it's simply not feasible to rely purely on clinical testing to run on the public, the overall public, and try to have leading indicators of how the pandemic is proceeding in terms of trends, in terms of whether in good control or if we're able to spot changes quickly. It's been difficult to do with clinical testing on its own. Usually people don't have a reason to do clinical testing until they start becoming symptomatic. And by that point, it's already too late. There's many people that are asymptomatic, but of course can spread it. And most people are aware of this now. And I'll say it again, as most people know that COVID caught us by surprise, unfortunately, that the programs were not really in place with in most areas, most geographies, and how to deal with this. So we learned as we went. So what we were able to find out is the wastewater-based epidemiology, which had shown some promise, but now has been put into overdrive as a result of the pandemic. We were able to spot some very interesting trends in terms of how the masses could be tested through testing the sewer shed and getting clues as to what's going on by that. In some cases, we were able to find that increases in COVID cases were predicted perhaps up to 7 days in advance of when the clinical testing would be done. Not surprisingly, when you look at the timing and the incubation period of the disease, that yes, this does seem like something that we should take a closer look at. So in some areas, we've had accounts of public, whether it's public health officials or otherwise, in some cases, private business have been able to take preemptive measures as a result of results that have come out of the wastewater-based testing prior to the clinical case counts coming up. So yeah, this, as I said, has turned into quite a valuable tool. The approach that's taken here, of course, as people shed viral material, it goes into the wastewater, it proceeds through the sewer shed. Samples can be collected either at the wastewater plant or perhaps within the sewer shed itself at various locations. And then using rapid methods, and PCR tend to be the tool of choice in most cases, you can get this sort of information in a fairly short order. Now, one of the things that we found out as we got involved with it is that people didn't really know a great deal about how to actually execute on this, whether it be municipalities or private business, but people seem to learn fairly quickly that if deployed properly, that this could be a truly valuable approach. And God willing, we are not exposed to another pandemic anytime soon, but if we are, this will undoubtedly be a tool that people will use. Whether it's, I mentioned about public health or private business, we've seen a lot of specific examples, whether it's long-term care homes or senior care homes, hospitals, schools, but more so dormitories, correctional facilities, and remote work sites. The thing that all of these examples have in common is that it's where people are actually living, and in some cases in remote areas that maybe typical services are not able to access in a short period of time. People have talked about things like mass transit, like airports and whatnot, but people come and go there. The trends that arise out of that may be difficult to draw any major conclusions, but in the examples listed on this slide, the people are more or less living in these areas, and in many cases in somewhat of a small footprint. So it presents the perfect opportunity to detect these kind of issues early on. So in terms of wastewater testing itself, there's certainly promise in using mail-in services and having third-party laboratories conduct this, but there's certainly also the downside of the turnaround time that's required for this. So collecting a sample, sending it off to a lab, it may take a day or two in transit, and then it makes its way into the laboratory queue. And maybe depending on how quickly the sample can be analyzed, then it may be a day or two until those results are available and then communicated back to the origin, the people they're managing the situation on site. And you may be looking at maybe best case 4 to 5 days. It could be longer than that. And then now we're losing the advantages of the early warning. So the goal in a lot of development work with companies such as ours was to increase accessibility to wastewater surveillance by developing an in-field or portable and user-friendly solution that would allow you to run these tests essentially on site to get same-day results or even faster than that. We had developed our GeneCount SARS-CoV-2 wastewater kit in 2020. Interestingly enough, we had launched the GeneCount qPCR platform, all-in-one workflow that was originally designed and intended to be used for industrial microbiology, for rapid testing of certain microbes that are involved in things like corrosion. Oilfield corrosion was probably the biggest one, but reaching into many others as well, Legionella. That was the goal of this product launch in late 2019, but something else that launched in 2019 was COVID-19. And so the timing was quite good. We were able to shift gears a bit and provide a SARS-CoV-2 assay as well as a COVID-19 clinical test. But what was not originally in the cards for this was wastewater, but we were able to come up with a method that instead of using the traditional lab approaches, such as the PEG method, which maybe takes several hours, maybe six or more hours in some cases, and concentration techniques, we took a little bit of a different direction here, going with a smaller sample size, so 1 mil, and magnetic beads to concentrate the virus that way, or to attract to the beads, and then a specialized method that would then wash the sample so that you then have eluted RNA that you can run the test for a turnaround time of about 2.5 hours. So very quick turnaround, fairly user-friendly, and something that's gained a lot of traction to get that quick turnaround that people need. There have been a few since we were more or less learning as we went, there were some improvements that were made along the way. But to give you a quick overview of how this works, it's as simple as adding your sample to a Lysis buffer to break out the RNA, have that available in solution. You add the beads to it, and then through a series of, in this case, through holding the magnet to the tube and pouring off the supernatant, you're left with extracted viral material, which is then washed using very much the same approach, where you're adding your wash buffers, magnetize the beads on the side again, pouring that off. Do this a few times with different washes as well as some ethanol, which again, same thing. You're then getting to the point where you need to elute the RNA off of the beads. So use your elution buffer, release the RNA from the beads, again with the magnet, pour it off, and you now have eluted RNA ready for analysis. So there's not any particular complex steps here. It's just a few pipetting, pour it off, repeat, and then you end up with a vial of that eluted RNA that's ready to go. There have been some improvements, as I said, that we've made to this over time. One of the issues was with ethanol that's required in the latter stages of the washing, and the ethanol can be highly inhibitory to this sort of analysis. So we've introduced a magnetic cap to collect the beads, which then allows the ethanol drawing to be more effective. As well as some enhancements in user experience and usability. Previously, we needed frozen storage for some of these reagents. They're now delivered in single-use freeze-dried aliquots. Makes things much easier, both in terms of shipping, storage, usability, and all of the above. The reduced pipetting steps also arise from that. So in addition to the storage and everything, it's just an easier test to run. And of course, it removes the fewer steps you have, the the reduction in user error that comes along with that also helps a lot too. In terms of inhibition, absolutely, you're dealing with wastewater chock full of things that would otherwise inhibit the reaction if you don't effectively deal with it. So there are some adjustments that were made there, increasing the elution volume from 50 to 100 microliters to make for to dilute out some of those inhibitors that may have remained. Those are all things that we now have arrived at the point where we feel it's a highly practical method that is especially designed for end users to be able to pull this off quickly and easily. But that is just the test itself. Now, something that was discussed at length in the panel discussion that preceded this session was sampling. And this was something that was a bit of a gap in the knowledge of not only the customer, but also on our side and how we might want to instruct users to draw samples, when, where, how often. This is something that we admittedly don't have a great deal of internal knowledge on, that we could provide specialized guidance in unique situations. But we were aware that, yes, there was some question of what is the best strategy, whether it's grab, composite sampling, which could be done via auto samplers, or a manual composite sample, or passive sampling, which is gaining quite a bit of interest and traction in terms of a viable, not only viable, but a very effective way of doing this. Considering the fact that the viral loading in the sewer shed is not particularly constant, you have highs, you have lows, and that will depend on a lot of things, the day of the week, the time of the day. People come and go, and yes, the loading in the sewer shed will vary. So getting it right is not a trivial matter. So we have, as a result of that, come up with a solution that we feel should be quite effective in this initiative. It's the device you see there. We call this the GeneWave composite sampling, or a passive sampler. It's about the size of maybe a large grapefruit. This is something that, and it has a lot of similarities to some, as I said, some of the things that were discussed in the panel discussion, where there's a composite sampler within this little ball. The ball itself is suspended in the sewer shed, and it simply will collect the viral material over time. There's no intervention needed here. It's just dropped in. When you then pull that ball out, you will disassemble it, remove the little filter pad, which has been gathering viral material ever since you put it in there, elute the viral material off, and there you have an excellent passive and composite sampler that will give you a great indication of what's been going on since the last analysis. Also highly cost effective. These are not particularly expensive to manufacture, so it's an easy entry to someone wanting to do perhaps several of these locations. If you look at some data comparing how these samples are gathered, just showing you some snapshots here. This one is of grab sampling. It's probably the most common method, but also it does suffer from some serious limitations in terms of timing. So the green bars represent sampling events. Here we have 2 within a day, and we have the wastewater concentration of the SARS those spikes perhaps due to increased loading in the sewer shed. They'll be completely missed. It's just a fact of grab sampling, is that yes, if you happen to catch something, you're getting specifically what's going on at that very time. But of course, if you don't sample at the right time, you're going to miss that. So composite sampling is a little bit better in terms of having better coverage. People do this manually, in some cases through some commercial auto samplers. Gives you those more frequent snapshots, of course. Tests one larger sample over the time period, so it's not going to tell you exactly what's going on at a specific time. It's more a story of the greater time frame. But of course, you do have the potential to dilute the signal out, and that, depending on the loading at that particular location, or whether if it's a sparsely populated area, you might not catch it there. It may be just too low for your test to pick up. But when you look at passive sampling here, so this, as I said, is more of a cumulative indicator of over time what are you getting. So you could have these spikes that are driving up the cumulative sum, and it's going to be more representative of trends. It's not going to say, okay, from this you can extract the number of case counts you might have, but it will certainly give you an excellent indicator of trends over time if you have a certain community or a certain area within the community, or perhaps, and one that we have very unique experience in is remote job sites. And this can directly indicate increased or changing in trends so that you may be able to act accordingly. Yes, it is semi-quantitative, but in terms of the value of the result and what this is going to do in terms of driving action, it's a highly effective method. So here's an example of some actual data using passive samplers. There was 2 different municipal sewer catchments here that were used. So location A, location B. There were 15 sampling events, and you can see that at location A, they had 7 positives, and at B, they had 5. But there were no, if you're looking just at the grabs, no SARS-CoV-2 detection in either one of them. So it just highlights the importance of the representative nature of the sample. And if you can use passive sampler to indicate this, then you're maximizing the likelihood of picking up these. So in terms of the next generation of wastewater-based epidemiology, and I will readily admit, and I will immediately acknowledge my co-authors on this and the ones that did just about all of the work on this, Dr. Jordan Schmidt and Helena Steves here from the LuminUltra team. They would be far more qualified to comment on this content than I am, but just a summary of what has been summarized here. The fact that antimicrobial drug resistance has now been declared one of the top 10 public health threats facing humanity. That is something that greater strengthens the importance of WBE tools and being able to get greater insight into the situation than what we have right now. That I guess the abundance or the frequency of having perhaps inappropriate antibiotics or overuse of antibiotics is leading to a ton of genetic mutations. So you're getting these AMR pathogens that are becoming more prevalent, and WBE is most definitely a great a step in the right direction to help deal with this sort of problem. So there's the WEF Public Health and Water Conference, I believe, is coming up at the end of March. I believe Jordan and Helena, I believe, are involved in that. So there's some interesting findings that will be coming out of that. In conclusion, as has been said by many in the panel discussion, and then as reiterated by myself earlier, WBE seems to be here to stay, and it's certainly it's a practice that's gaining more use as a result of the pandemic and should have plenty more utility in the future. And we're proud to be involved in this sort of cutting-edge research, but not only research, but also to develop commercial solutions that can be applied directly to it. We did take a few swings at this one to get it right. Our method when we began was quite solid, but we've made it a bit better to account for certain things like usability, removal of interferences, accounting for inhibition. That was, I think, those were all positive improvements to the method, but then I think the one that really is going to bring the greatest benefit is the introduction of the passive sampling, because then we're not just talking about the test, we're talking about the data itself and the actionability of it. But overall, the industry in general, I think, moving in the right direction and continuing to take this more holistic approach to WBE as a form of public health monitoring, and build upon this, build upon current WBE initiatives and applications for the future. I want to thank you all for your attendance. Happy to further discussion or any questions that you have. Interested to hear what everybody thinks.
Thank you, Dave. Indeed, there was a few questions asked. So you mentioned about the health regulations. Do you see WBE becoming as a new mandatory field? Out of your lobbying, out of what you hear in the market, do you see it's becoming a new mandatory field for Europe, for example, in the future, or other markets?
That's a great question. I know that there were some mandates within Europe that were, in terms of WBE and in directly relating to COVID-19. There were some countries that I think that was met with some acceptance. There was some pushback there. I think that the application as a whole is still young, so it's hard to predict. I think that you may see in the coming years, especially depending on how COVID plays out the next little while, we may see more pressure on this sort of thing. The other factor that I didn't really get into a whole lot was the lack of a standardized method for this. So there's a lot of different labs have different methods, universities, we've seen many different approaches. There'd probably be a little bit of standardization that would be needed prior to any mandated instruction from government.
Thank you. And one other, this question was from Mr. George Jurgolitis. The next question came from Professor Vogel. It's specifically about your technology. With your passive bowl, sampler bowl, have you tested it at different scales, like manhole facility, check clean out, treatment plant? He would wonder about accumulation of solids, like toilet paper, especially at the smaller scales, where flow rate is slower.
I can't speak on the actual number of sites that has been deployed in. I'm not directly involved in that development work, but I know that it's been tested extensively in the Northeast here, as well as in Northeast Canada and the US. But I know that it's been trialed at both municipal as well as industrial situations. It's fairly well torture tested by this point, but I can see if maybe it's something we can discuss offline, and I can connect you with people that were more directly involved with that.